This is going to be our second standard access lists exercise. We will use the same topology we used in our second router on a stick exercise. Everything is already configured, and the only thing we need to do is ban all communication from VLAN 700 to VLAN 800, but allow all communication in opposite direction. So PCs in VLAN 700 are colored blue, and PCs in VLAN 800 are colored pink. Let's check if everyone can communicate with each other, because that's a prerequisite anytime we want to work with access lists. So, okay, the first pings are probably going to fail because of ARP tables. Everything seems to be working properly. Okay, let's look again at the task. So we should ban all communication going from VLAN 700 to VLAN 800. And as I've mentioned in the previous exercise, when we are asked to do something like this, we should first look at how that traffic flows. So if we look at PCs belonging to VLAN 700, those are the blue PCs, their communication with VLAN 800 is going to look like this. First of all, we need to look at which interface on this router on a stick is a gateway for VLAN 700 computers. So VLAN 700 is configured on router 1 interface fast Ethernet 0/0. So the packets going from blue computers or VLAN 700 computers will go to this interface right here to be routed elsewhere. VLAN 800 is configured on router 1 interface fast Ethernet 1/0. That is this interface right here. So if PCA, for example, sends a packet to PCB, that packet will go to switch 1, switch 2, fast Ethernet 0/0. That's the gateway for VLAN 700. And then that router will route that packet to this interface, which is the gateway for VLAN 800, and then that packet might use this route or this other route to reach switch 1. Again, it depends on the spanning tree protocol and the spanning tree. But we don't really need those details. We just need to know which interfaces that traffic is going to go through so that we can figure out on which interface to configure our access list. I hope it's obvious that we should block this traffic in the outgoing direction on VLAN 800 interface. Let me get into details on that. If PCA sends a packet and that packet goes to fast Ethernet 0/0 interface, if we were to block all packets with source IP 1070, on that interface, we would simply block all traffic going from VLAN 700 computers because we would drop those packets before they can be routed to other VLAN networks. This way, since we want to only block those packets going from VLAN 700 to VLAN 800, but not other VLANs, we are going to focus on VLAN 800 interface, and that interface is this fast Ethernet 1/0, and more specifically, similar as in our previous exercise, we had frame relay, but here we have router on a stick, and we also have these virtual sub interfaces. So this time it's going to be fast Ethernet 1/0.800. This is the interface where we will be configuring our access list. What will that access list look like? Well, similarly to our previous access lists, we're going to have only one deny statement. It's going to be deny this VLAN 700 subnet and then permit everything else. And then we're going to apply that access list to this interface in the outgoing direction. So let's do that once more. I just want to make sure that I have tested the communication between these two VLANs that we want to block. Okay, it's working. We're going to start with creating the access list on the router. We have DHCP configured here, so we're getting some DHCP conflict. That's obviously resolved because we only got several of these messages. Configure terminal, and then I'm going to say IP access list standard, and then let's call it number 1. Deny. Network address for VLAN 700 is 10.7.0.0, and then the mask is 0.0.0.255. And then don't forget to permit all other traffic, because if we left it like this access list would actually block everything. Now we want to get into this fast Ethernet 1/0 interface, but specifically we should use its subinterface. And then we're going to say IP access group 1 out. Now let's test those pings. I'm going to try to ping from PCE to PCI, and that failed. I want to look at the simulation to make sure that that ping failed only because of the access list. Remember, this packet has to come in through this interface because that is the gateway for VLAN 700 or to Blue computers. And I'm going to guess and look at this packet right here. And we will see that the packet matches the criteria of the following statement, blah, blah, blah. So our ping was indeed dropped because of the access list. We were also requested to make sure that we only block this communication in one direction from VLAN 700 to VLAN 800, but let it go in opposite direction. The trouble with that is that with ping, you can't really easily test that because ping is an echo, so you will be able to send the packet from, for example, PCD to PCH. And that is going to fail because from PCD to PCH it should work, but then when PCH wants to return that ping back, the router is going to drop the packet because of the existing access list that blocks PCs from VLAN 700 from sending packets to VLAN 800. But let's look at the simulation to see if that communication in the direction from VLAN 800 to VLAN 700 actually works. So we need to see this packet reach PCH, but then when PCH sends it back, then it should be dropped. Okay, we can see that that packet went in there and now is going back. PCH has received the packet and then it sends it back, and only then is that packet dropped. Let's look at the reason. The reason is, of course, the access list.